Good morning, pre-calculus. Today we're going to look at section 9-2, dealing with arithmetic sequences and partial sums. So without further ado, Mudrock, hit the lights. All right, so the essential question for today is how do you find the nth term or the partial sum of an arithmetic sequence? So today we just have a few examples to show you. It's a relatively easy section. I think you'll have absolutely no problem. So starting right off the bat, Roman numeral 1 deals with arithmetic sequences. In your book, it's on pages 653 through 655. And then these are the two formulas or equations that we gave at the beginning of chapter 9, section 9-1. And I think the only way to do this is just by examples. So what we want to do is example number 1, find the nth term. Now when it says that, that means like, what if I want to find the 20th term? Or what if we want to find the 172nd term? Okay, so find the nth term of the arithmetic sequence with a common difference of 5, and the first term begins with 9. Now remember, we're dealing with a arithmetic sequence. So now from one term to a next term, we're either adding by a value or we're subtracting by a value. So by as example here, we know this one has a common difference of 5, and we know our first term is 9. So we know that our second term will be 9 plus 5, which would be 14. Our third term will be 14 plus 5, which would be 19. So in other words, each of the terms are increasing by a value of 5. So what I'm going to do is use this part of the nth term of the arithmetic sequence. So again, this part right here is reminding us that this is the term that we're trying to find in the sequence. So you could find the 27th term. One thing you need for this question is you need to know what your first term is. The n represents the term we're trying to find, and the d once again is your common difference. So again, you look at your sequence. If it's increasing by the same value or if it's decreasing by the same value, that's your common difference. So setting this one up here, we know now that our problem is going to be set up to be first term is 9. And we know our common difference is 5. Do a little bit of algebra here, and this is our equation. So this is the nth term of an arithmetic sequence. So we can figure out any term of the sequence by letting, again, just as an example, if I want to find the fourth term of the sequence, I let n become 4. So 5 times 4 is 20, plus 4 is 24. So the fourth term in the sequence is 24. All right, now, the next problem, they get a little bit a little different information, okay? They're telling us that the 8th term of the arithmetic sequence is 25, and the 12th term is 41. And we want to write the first 5 terms of this sequence. So for us to do anything, we got to be able to get our problem set up into either of these two equations. Here's how I'm going to do it, okay? Well, we already know the 8th term is going to be 25, and we know the 12th term is going to be 41. But we don't have any other information. We don't have the 9th term, we don't have the 10th term, we don't have the 11th term. So what we can do is take the 12th term, the value of the 12th term, subtract from that the 8th term, and divide it by number terms. So in other words, 12th term by the 8th term is the 4th term. That's where I get the 4. Do a little bit of math. So 16 divided by 4 is 4. So this is your common difference. All right. So we know our common difference, or our value of d, is going to be 4. So we go back up to this equation right here. We know already that the 8th term of the sequence is 25. We don't know what the first term is. That's what we're going to try to find. Once we find the 4th term, everything's hunky-dory after that. So, okay, we know the 4th term is 25. We know that this part right here is the difference of your terms. So 8, which is the 8th term minus the first term, times the common difference. All right, do your math. 8 minus 1 is 7. 7 times 4 is 28. Subtract 28 from both sides, and we see that a sub 1, or in other words, the first term of our arithmetic sequence is negative 3. So we know our first term is negative 3, and we just, common difference is 4, so we add 4 to each of these terms, and that will give us the first 5 terms of the sequence. Pretty cool. Relatively easy. Just it's not that difficult. You can follow it. Once again, this information is found on page 653 through 655 in your book. You'll be able to follow that stuff. You'll have absolutely no problem. All right, let's go to the second part. Roman numeral 2 is find the sum of a finite arithmetic sequence. Now, what does that mean? Well, let's go back here to this previous problem right here, okay? Here is the first 5 terms. 1, 2, 3, 4, 5. First 5 terms of this sequence. The next section is, what if we take these 5 terms and add them up and get a value, and that right there is what we call a partial sum, or leads up to the discussion of a series. So again, if we were to add these 5, that will give you the partial sum from the first term all the way up to the 5th term. Okay, that's a partial sum. We're just doing part of it. So best way to do this is by example. So Roman numeral 2, the sum of a finite arithmetic sequence, we'll be using this formula right here. So this big capital S means summation. Summation of what term? So in other words, we're starting from the first term all the way up to the nth term. So you take your nth term, multiply it by what is your first term of your sequence and what is the nth term of you're adding up to. So if we're trying to figure out, if we're trying to add up from the first term to the 5th term, we need to know what the 5th term of that sequence is, divided by 2. And we can also do this on the calculator. Again, down here is the formula. Again, to get this one, just once more, I'm going out of sync of what I wanted to say. You just go to your calculator, go to math, and find the button that says summation. And then it's telling you where you're going to start, what term you're going to start at, what term you're going to end with. So I'll do this in a second, okay? Well, I'm just going to do it without using the calculator. So we want to find the 15th partial sum of the sequence. So in other words, we want to find out, we want to add together the first term all the way up to the 15th term. So the first thing we got to do is, in order for us to do this part, we want to find the sum of the 15th term. N is 15, but we need a couple of information. We need to know the first term, which we already know is 2, but we need to know what the nth term is. In other words, we need to know what the 15th term is in order to do the summation. So all the work over here is setting up our equations so that we can find the 15th term. So going back, we know that a sub 1 is 2. That's the first term of the sequence. We're trying to, then we take the 15th term minus 1 and multiply it by the common difference. Once again, the common difference comes from looking at your sequence of numbers. And if you do your math, we notice that the 15th term is 44. Now we can also, from here, we can figure out what our equation is based upon the last section, the beginning of this section. So in other words, we could figure out that the 15th term of this problem, be 3 times 15 is 45, take away 1 is 44. So now we found our 15th term. So now we want to sum it, so it'll be 15 times the sum, or whatever this is, whatever, let's keep going, Mr. Cornish. 2 plus 44 divided by 2, and that will give you a total value of 345. And you can do the same thing on your calculator. Did that, and I'll do it again. Again, I'm going to use x. We want to start off with the first term, and we want to go up to the 15th term, and we need to know what the equation is. Hit enter, and you get 345. Are you with me? All right, now, number 2 is we want to find the 50th partial sum of the sequence of -6, -2, 2, and 4. So in other words, we want to add up the first term all the way up to the 50th term of this sequence. Well, the first thing we got to do is we got to figure out what our 5th term is. But the first part right here is finding that, again, nth term of an arithmetic sequence. So this is our nth term of our sequence. Because all we need, if you can remember, all we need to do this is we need the first term of the sequence and we need the common difference, and a little bit of algebra we'll be able to figure out the equation. Okay? So we found out now we want to find the 50th term, so we let n become 50. So 4 times 50 is 200, take away 10 is 190. So the 50th term of this sequence is 190. So we just plug it back into the summation. Okay? We know that n is 50. That's the 50th term we're going up to. -6 plus 190 divided by 2, and we get 4,600. And again, you can also do the same problem by using your calculator. Math, summation, starting off with x, starting off with the first term, and we want to find the 50th term, and we need this equation. So it'll be 4x minus 10, enter, and there you go, 4,600. Again, hopefully that was a relatively easy section. Put some thinking into it. All remember, okay, I think you guys can handle it. So how do you find the nth term or partial sum of an arithmetic sequence? Hopefully this section was very helpful. Have a good time working these out. I'll catch you guys later.